Okay, in this tutorial we're looking at 2020 paper 2 question 4, which is based on trigonometry. We're asked to find the two values of theta for which tan theta over 2 is equal to minus 1 over root 3. The first thing that you should recognize is that if the question says theta over 2, the way that you should view it is it's a half theta. And remember from the tutorials that we've done on the unit circle, if there's a coefficient in front of theta, the first thing you should do is change your domain. So the question is asking me to get theta between 0 and 4 pi. So that means what I'm actually going to do is I'm going to get a half of theta between 0 and 2 pi. I'm halving the domain. Remember, 2 pi is 360 degrees. So this simply means we're doing one full revolution of our unit circle. Now, the next thing that we should do is work out our reference angle. The reference angle has to be in radians because the domain is given in radians. So if you get tan inverse of 1 over root 3, again, you ignore for the moment, when we're getting a reference angle, you ignore the half and you ignore the minus. Just work out when is the tan of an angle equal to 1 over root 3. So you get tan inverse of 1 over root 3, or you read it off page 13 in your maths tables. Either way, you're going to work out that your reference angle is pi over 6. And now I need to work out in which quadrants in the unit circle is the tan of an angle negative. I know the tan of an angle is negative in the second quadrant and in the fourth quadrant, in S and in C. Now, to get an angle in the second quadrant, we always start at 0, and by the time we've done half of a revolution, we're at 1 pi, or in other words, 180 degrees. So to get my value in the second quadrant, I'm going back into the second quadrant. So to work this out, I'm at pi, and I'm going back into the second quadrant, so I'm subtracting my reference angle. Pi minus pi over 6. My first answer gives me 5 pi over 6. So the first point on the unit circle, when the tan of an angle is equal to minus 1 over root 3, is 5 pi over 6. But I also need to get a value in the fourth quadrant. And by the time you get to the fourth quadrant, you've done full revolution, so you're at 2 pi, and you're going back into the fourth quadrant. So to get a value in the fourth quadrant, it's 2 pi minus pi over 6. 2 pi minus pi over 6 gives me 11 pi over 6. So my two values at the moment are 5 pi over 6 and 11 pi over 6. But you should recognize that in everything I've done here, I've ignored the fact that there's a half there. So I have actually worked out that a half theta, or theta over 2, the answers are 5 pi over 6 and 11 pi over 6. But obviously I'm not interested in half of theta. I want to work out what is theta. If you know half of theta, to get theta on its own, you multiply everything by 2. So my actual answer is, if I multiply everything by 2, 5 pi over 6 multiplied by 2 is 5 pi over 3. And 11 pi over 6 multiplied by 2 gives me 11 pi over 3. So my two answers for theta, 5 pi over 3 and 11 pi over 3. In question 4 part B, we were given the sector of a circle that has a radius of 7 centimeters and the angle at the center of the circle is 1.2 radians. Now, the sector has been divided into 2 and we've been asked to work out the distance from B to C. Now, we've been told that the area of the section ACB is 21 centimeters squared. And the question is, I need to work out my distance here. The key is that you know the distance from B to O is 7 centimeters. So what we're going to do in this question is to first work out the distance from C to O. Once I've worked out the distance from C to O, I'll subtract it from 7 and I'll end up with the distance from B to C. What you should recognize is that from A to C to B, that's an obscure shape. We've never dealt with a shape like that. However, ACO is a triangle. We spent loads of time studying about triangles, so this is the one that I want to hone in on. I certainly should be able to work out the distance from C to O using my knowledge of triangles and my knowledge of trigonometry. The first thing I decided to do here was to get the area of the sector. According to page 9 in the maths tables, to get the area of a sector, when the angle is given in radians, it's a half by r squared by theta. In this case, the r is 7 and theta is 1.2. If you plug that into your calculator, the area of the entire diagram is 29.4 centimeters squared. If I then subtract 21 from that, it gives me 8.4 centimeters squared. So this allows me to determine that the area of this triangle is 8.4 centimeters squared. So it's obviously, that's the only information I can really take from the diagram. So it must be something to do with getting the area of a triangle. On the Leaving Cert High Level course, there are 3 different ways in which we get the area of a triangle. One of them, if you have a right angle triangle, you can use half the base by the perpendicular height. Although it might look like it here, there's nothing to indicate that this is a right angle triangle. Another one is there's a coordinate geometry formula, but you can't use that unless you know the coordinates, and this has nothing to do with coordinates. The third way that we've explored getting the area of a triangle is from trigonometry. The area of a triangle is calculated as a half AB sine C, where C refers to one of the angles in the triangle, A and B refers to the sides either side of the angle. So in this case, look at the triangle ACO. The 2 sides that I'm talking about here are AO is 7 and CO is the unknown. Don't know what CO is for the moment, but I know the angle in between them is 1.2, and I know the area of the triangle is 8.4. So if I sub into this formula, the only thing I won't know is the distance CO, and I'll be able to work it out. Now, obviously this is in radians, and if we're about to get the sine of an angle in radians, you gotta have your calculator in radians. So that's the first thing that needs to jump into your head. Let's sub in here. The area of the triangle ACO is 8.4 centimeters squared. And that is equal to a half multiplied by a side 7, and then the other side I'm going to multiply it by is the distance CO multiplied by the sine of the angle in between them. In this case, the sine of 1.2. If I have my calculator in radians, sine 1.2, I'll be able to work it out. And my goal is to get CO on its own. I have one equation and one unknown, so it's going to be relatively simple to figure this one out. What I'm going to do now in my calculator, I'm going to multiply a half by 7 by sine 1.2. So I finished this one off here. I multiplied a half by 7 by sine 1.2. Once my calculator is in radians, I get 3.2621. Then divide both sides by the coefficient of the unknown, and I get the distance CO is 2.575. The distance from C to O is 2.575, and I know that the radius of the sector from B to O is 7 centimeters. I simply subtract my answer. I subtract the distance CO from the radius, and I'm left with the distance BC to 1 decimal place is 4.4 centimeters.